Hello everyone and welcome back to a new video. So in this video we are going to discuss about the pointer arithmetic as told or discussed in the previous video. Okay, so normally we perform addition, subtraction and different type of operation on normal integer type of variable or floating type of variable. But in pointer arithmetic we can also perform these things in between pointer type of variables, means in between addresses. Okay, so for that we have to learn how it is performing. Before that, let's read this paragraph. That pointer arithmetic is the set of valid arithmetic operations that can be performed on pointer. The pointer variable store the memory address of another variable. Definitely we have studied about it. It does not store any value. Definitely it stores an address pointer variable. Hence there are only a few operations that are allowed to perform on pointers in C language. The C pointer arithmetic operations are slightly different from ones that we generally use for mathematical calculations. Their operations are means the operations which we can perform on pointers or in between the pointers are mentioned below. The first one is normally increment, decrement of pointer. Mean increment means increasing by 1. Now that 1 refers to the size of that variable it is storing, like the address of which variable it is storing, or the type of the pointer mainly. So means what? Means here this pointer, let me remove this thing. Okay, now here you can see this pointer is storing or pointing to a integer type of variable. So now in that case generally plus 1 or increment means plus 4 in the address, initial address. Okay, means if the initial address is 1000, then after increment the address will become 1004. So this is like that the increment. Similarly decrement also means in minus 4. Okay, it is based on the like computer architecture. So if it's a 32-bit computer and if it's a 64-bit computer, then the size of integer definitely will be different and the increment and decrement will be in different amount. Okay, now addition of integer to a pointer, we can add an integer to a pointer. In that case we'll be discussing that. Let's say we have taken a integer 5. So whenever we are adding that integer, okay, means we are adding plus 1 into 5, means 5 plus 1 means 5 time increment, and 5 time increment in integer type means 5 into 4 means 20. Total 20 increase in the address, in the initial address. So that is the thing we'll be discussing about it. Next, subtraction of integer to a pointer, similar thing but it is in negative. Subtraction two pointers of same type. Okay, and comparison of pointers. Sorry for the background noise. uh, okay, now so increment and decrement of pointer. Here is some definitions are given. Likewise, I have given you, let's say the initial address is 1000. So after increment, if the size of the integer is 4, let's say it's an integer type of pointer, then after increment it will become 1004. Okay, that is the thing. While if a float type pointer is incremented, then it will increment the size or incremented by 4. Size of float is 4. whatever whatever it is, actually the main thing is whatever the type of the pointer, whenever we are increasing the value of it or doing pointer plus plus or this type of operations, or pointer equal to pointer plus 1, then it will be increased by how many times we are increasing multiplied by the size of the data type of the pointer. Okay, and the new address will be 1004. So like that is the thing. Don't go over it. Let's see this structure, what is it is telling. Okay, now let's say initially the pointer is here which is pointing to address value of 1000. after doing this operation pointer plus plus means uh, increment. Okay, post increment. So post increment we are doing here, although if we do it before printing it, then it will be like normal increment. Okay, means it will be equivalent to pointer equal to pointer plus 1. Okay, so that is the thing. Now we are increasing it, and this pointer is an integer type of pointer, so after increasing plus 4 bytes will be added to that initial address, and now the value of the pointer, it will be pointing to the address 1004. Okay, similarly whenever we are decreasing means pointer minus minus or pointer, actually this ptr is the ptr variable where we have stored the initial address. Okay, now if we decrement it, then it will be decremented or in negative means minus 4, it will be pointing to a like previous address. Okay, means this is 1000, we have decremented it, so it will be minus 4 and it will be now pointing to the address 996. Okay, as calculated. Now there is a note that it is assumed here that the architecture is 64-bit and all the data type are sized accordingly. For example, integer is 4 bytes, like they have told that uh, in 64-bit architecture the size of the like integer is 4 bytes. So that is a simple thing, we need not to worry about that. But now below is the program for illustrating pointer increment and decrement operations. Okay, now if we perform some operations, let's say here is our program and this is a variable, we are printing it, right? Now if we run it, you can see a value like that, f44 something. This is in hexadecimal format. Let's do an experiment. Let's increase it or pre-increment it, then let's print the value in the next line. Okay, let's run it. This is coming out like that, and before that what was there, if we run it, you can see like this is coming out like 848e4, remember it. Okay, or we can do another thing, just copy it. Let's see before pre-increment. Okay, just remove it, this is not needed. This is before pre-increment and this will print after pre-increment. Okay, so let's print the things. I think there is some problem. Okay, we have done a mistake actually. Actually we have to pre-increment it, but mistakenly I have put it before the declaration, pointer declaration, and this is not like the good approach. This will definitely create a error. So now here we are pre-incrementing it. I hope you have understood. At first we have declared a variable where we have stored 10. Okay, now we have declared a pointer where we are pointing to that variable, or mainly we are storing the address of that variable. Now we are printing the value of pointer means the address of that variable. So let's run it, and after that pre-incrementing and then after incrementing the ptr value, sorry, here actually it will be ptr. Okay, ptr, because we are increasing the value of the address. Okay, now if we run it, this is giving a value like that. Okay, this is actually what, this is before incrementation. Okay, before increasing the value, before the increment operation, the value is like that, the address value. Here follow the last two digit. Okay, this is 24. Now in next step we have incremented, pre-incremented, and after that we are reprinting it. Reprinting the value of PTR means which is holding the address. So the updated is 28, the last thing. So here you can see this is incremented by plus 4 as it is integer type. Now similarly, if we change the type of that variable, okay, let's care and let's change it to, let's say, any character, let's say capital A. Okay, after that let's also we have to change it because we are pointing to a character type of variable. Okay, now let's run it. I think there is a problem, like we are actually uh, storing a string, which is wrong, but we have to store a character. So a is undeclared mainly. Okay, first use this function. Just a second, this is a cat type of thing, so just let me debug and after that I will show you that thing. Okay, there was a small problem that we have used double quote. Instead of this we have to use single quote and store that character. Okay, let's say we have stored a. Now I have run the program. Let's rerun it. So you can see the initial address is 67 before increment, but after that the address is 68 because character type of variable or character, this type holds one byte in the memory in a 64-bit or 32-bit computer, 32-bit architecture. Okay, so that is the thing. It depends on the type of the variable you are pointing to or your pointer is pointing to. If we change it to string, this will be different. If we change it to like double, okay, this will be different. So it will be like it can be changed. Okay, so that is the thing. Let's remove this thing and initialize it to the previous one. So that is the thing. Okay, and now what will happen, just a second. Now what I was talking about is that if there, this is the incrementation. Okay, now if we decrement it, then the same thing, it will go before that address. So like if we run it, here you can see initially the address is 74, but after decrementation or decrement, this is 70. Okay, so this is the thing. Now if we like plus plus then do this, let me do plus plus and then I am doing this. You can do different type of experiment using this. Okay, that is not a factor. So initially the address is 34 and then 38. Okay, so the same thing is happening, it doesn't matter. Now let's increment, pre-increment or post-increment inside it. So now what will happen? Let's okay, now you can see the change that we are printing the value of PTR, then we are increasing. So that's why value is unchanged. Okay, now if we do pre-incrementation operation, now we have pre-incremented the thing or the pointer or the address, then we are like printing. So in that case the result will be like the previous one. Okay, initially the address is 14 and now the address is 18. So that is the thing. Okay, similarly you can experiment with pre-decrement and post-decrement operator also. Now that is the thing. In next video we will be discussing same code, like same type of codes are explained here. You need not to study about it, but you can refer this article from GFG's C language pointer. You can search on Google. So that is the thing. Okay, now in next video we'll be discussing about the second type, which is addition of integer to a pointer. Okay, thank you for watching this video.